Let's dive into buffered channels in Go and see how they enhance coroutine communication. Buffered channels allow you to send multiple values before a receiver is ready, improving concurrency and performance. To create a buffered channel, specify the capacity in the make function. You can send values to a buffered channel up to its capacity without needing a receiver to be immediately available. When you receive values from a buffered channel, it operates like an unbuffered channel, blocking if the channel is empty. Here's a complete example demonstrating buffered channels in action. Buffered channels are an effective way to manage communication between coroutines. Start using them to enhance your Go applications. Let's explore the select statement in Go and see how it enhances channel handling. The select statement is used to wait on multiple channel operations, allowing coroutines to handle communication more effectively. The basic structure of a select statement is as follows. You can use select to perform actions based on which channel receives a value first. The default case in a select statement is executed if no other cases are ready, allowing you to handle situations when no channels are available. Here's a complete example demonstrating the select statement in action. The select statement is a key feature for managing multiple channel operations in Go. Start using it to streamline your concurrent programming. Let's dive into mutexes in Go and learn how they help synchronize access to shared resources. A mutex, or mutual exclusion, is a synchronization primitive that protects shared data from being accessed simultaneously by multiple coroutines. To use a mutex, you need to import the sync package. Create a mutex by declaring a variable of type sync.mutex. Use the lock method to acquire the mutex before accessing shared data and the unlock method to release it. Here's a complete example demonstrating mutex usage in a concurrent program. Mutexes are essential for preventing data races in Go programs. Start using them to ensure safe access to shared resources. Let's explore wait groups in Go and learn how they help manage concurrent tasks. A wait group is a synchronization primitive that allows you to wait for a collection of coroutines to finish executing. To use a wait group, import the sync package. Create a wait group by declaring a variable of type sync wait group. Use add to specify how many coroutines to wait for, and call done when a coroutine completes. Here's a complete example demonstrating wait groups in action. Wait groups are essential for managing concurrency in Go. Start using them to ensure your main program waits for all coroutines to finish. Let's dive into working with time in Go and discover how to manipulate time effectively. To work with time, you need to import the time package. Get the current local time using the now function. Format time using the format method, which takes a layout string. Parse a time string into a time object using parse. Use duration to measure time intervals. For example, sleep for a duration. Here's a complete example showcasing various time functions. Working with time is crucial in Go. Explore the time package to harness its full potential. Let's explore timers and tickers in Go and learn how to manage time effectively. A timer allows you to execute a function once after a specified duration. Create a timer using timeAfterFunc, which schedules a function to run after a delay. Timers can also be stopped before they execute using the stop method. A ticker sends signals at regular intervals, allowing you to perform tasks repeatedly. Create a ticker using timeNewTicker, specifying the duration for the ticks. Use a loop to handle tick events and perform actions at each interval. Here's a complete example showcasing both timers and tickers in action. Timers and tickers are powerful tools for managing time in Go. Start using them to enhance your applications. Let's dive into working with JSON in Go and learn how to manipulate data effectively. JSON, or JavaScript Object Notation, is a lightweight data in-array format that's easy to read and write. To work with JSON, you need to import the encoding JSON package. Convert Go data structures to JSON using the JSON Marshal function. Parse JSON data into Go data structures using the JSON unmarshal function. Use struct tags to specify how fields should be encoded or decoded. Here's a complete example showcasing encoding and decoding JSON. Working with JSON is essential for data in-array in Go. Start using the encoding JSON package to manage your JSON data.